Hello, welcome to Andre's The Tech Enthusiast channel. In this video, I will show a demonstration on one of the software-defined infrastructure solutions from Dell Technologies called PowerFlex. PowerFlex is a massively high-performance, scale-out, and distributed storage architecture using standard x86 servers and ubiquitous Ethernet networking. PowerFlex is also known to support multiple environments like multiple hypervisors, bare metal operating systems, and containers or Kubernetes. In this demo, I will show PowerFlex performance using FIO benchmark tools and demonstrate how the parallel communication is happening using PowerFlex Manager. In my demo environments, I have 6 PowerFlex storage nodes or SDS. Each of the node have 10 by 1.6 terabytes NVMe SSD for total 60 by 1.6 terabytes NVMe combined in a storage pool. From the storage pool, we have created 24 volumes and mapped them to PowerFlex Compute Nodes or SDC. We have 2 SDC hosts running VMware vSphere and another 2 SDC hosts running bare metal Linux. Okay, first let's get into our jump hosts here. Let's open PowerFlex Manager using Chrome browser. Let's enter our username and password and click Login. Now we are on the PowerFlex Manager dashboard. Here you can see the overall performance of the storage system. You can see aggregate IOPS and throughput in last 1 hour. For more performance metric retention, we can use solutions like Grafana. Let's also open Grafana to see the history of performance of the system. Let's go back to the dashboard. I've done benchmark test few minutes ago and it showed in the chart it reached more than 1 million IOPS and throughput about 4 gigabytes per second. You can also see the latency always under 1 millisecond. You can also see storage capacity and capacity being used. Data savings also shown here with storage efficiency ratio is shown, which are the result of compression's efficiency. Currently we use medium granularity storage pool where we disabled the compression. To enable them, we need to use fine granularity storage pool type. You can also see from the resources/inventory we have total of 10 nodes and 2 switches. Out of 10 nodes, 6 nodes are storage nodes or SDS, which are configured in one protection domain and one storage pool, just like what we explained in the deck earlier. Now let's take a look on the SDSs or the storage nodes. We have 6 SDS here with different IP addresses, and please note also the capacity are distributed evenly across all SDSs. All SDSs are part of one protection domain called SDS-PD1. Now let's take a look at the SDC or the host level. We see that there are actually 6 SDC connected to the system, although in this demo we only use 4 of them, which are 2 ESX nodes and 2 bare metal Linux nodes. You can also see mapped volumes to the hosts. Think of them as LUN presented to the hosts, just like when you are working with SAN storage. Now let's get to most interesting part, measuring PowerFlex performance. We go back to our PowerFlex Manager dashboard and see there are currently no activities. Let's open our terminal sessions using MOBA Xterms. Open SSH session to 4 worker VMs running on 2 ESX hosts and 2 bare metal Linux hosts. We want to examine the mapped volumes as target for our FIO benchmarks, pushing the IOs to the PowerFlex storage system. First, let's take a look at one of the physical Linux hosts and see the directory structure. These are actually internal OS directory hosted on BOS card. Let's see other devices presented to this hosts using lsblk command. We can see the mapped volume presented to this hosts with prefix SCINI. These are the target volume for FIO benchmark tools. PowerFlex compute node typically does not have local disks except for BOS card or boot optimized storage solution. Storage for application will be provided from PowerFlex storage by installing PowerFlex SDC software on the operating systems which enable parallel communication to PowerFlex storage. These where you see the mapped volume coming from PowerFlex. Let's use multi-exec feature from MOBA Xterms where you can type commands to multiple sessions at once. We have created predefined benchmark profile which includes parameters such as read and write percentages and I/O size. Let's use 80% read and 20% write and 4K I/O size to simulate an OLTP 4K workload on PowerFlex system. Let's execute the benchmarks at once and see how it goes. The FIO benchmarks now start to pump multiple threads of I/O to the volumes. We should be able to see some activities in the PowerFlex Manager dashboard. We can see now they are actually hitting 1.1 million IOPS with 4.3 gigabytes per second bandwidth. This is actually the same profile that we ran previously, so the chart looks consistently hitting the same values. This is quite remarkable considering it's only a 6U storage compared to any high-end storage. And this is just the beginning. Let's take a look now how those performance is being delivered through PowerFlex components. Let's start with protection domain. Protection domain groups SDSs under the same isolation group so they are isolated from performance, capacity, and access. You can use protection domain for multi-tenancy purposes, for example. As we currently only have one protection domain in this system which group all the 6 SDSs, then the performance metric for this protection domain should be similar to that shown in the dashboard. Now, let's take a look those performance metrics at each of the SDSs and see how it is evenly distributed. Each SDS is participated in one protection domain and holds number of devices or disks. The read or write I/O coming from SDC will be parallelly distributed to all the SDSs and its disks. Let's customize the appearance of SDS's report by adding performance-related columns. Now we can see the total IOPs and bandwidth and also granularly per read or write. You can see it's pretty even. Each SDS gets the same IOPS bandwidth. You can see also the read number is higher, so it is aligned to the FIO benchmark profile that we use. If you aggregate the performance metric of each SDS, you get the same total number per protection domain or per system. This massively parallel I/O distribution proves that PowerFlex can maximize the potential of each nodes and disks without any hotspots. Let's look again at the latency. Latency is consistently stable under 0.5 milliseconds. This is truly characteristics of an enterprise high-end storage. Let's now see the performance metrics distributed down to the devices or disks level. You can see each of the devices out of total 60 devices get the same capacity used. The devices are grouped into a storage pool. We might want to separate storage pool for different type of device, for example pool for NVMe and pool for SSD. Volumes can be dynamically moved to different storage pools non-disruptively. Let's customize the devices report by adding performance-related columns. Now we can see from performance perspective it is awesomely even. Each disks get about the same IOPS, bandwidth, and latency. This also proves no hotspots. PowerFlex can potentially use all the disk capabilities and preserve the endurance of the SSDs evenly. The total of IOPS, bandwidth of the all disks will be the same as total of IOPS and bandwidth per protection domain and per PowerFlex system, as we only have one protection domain. If you aggregate the performance metrics of the disks per SDS, you can also see the same total IOPS and bandwidth of that particular SDS. One more PowerFlex component that I would like to show obviously is the performance metrics from the hosts or SDC side, because this the actual front-end performance metrics which the application or virtual machine is using. Let's take a look at the host reports. As usual, because by default the reports does not show the performance metrics, let's customize it by adding performance-related columns. Here you can see that PowerFlex deliver massive performance to each of the SDC or hosts through their mapped volumes. Remember, at this demo we are only using 2 ESX node and 2 bare metal Linux. Please ignore the Oracle node there. The total of those front-end performance delivered to all the hosts that participated in the benchmarks are equal to the performance in the back-end from PowerFlex system or protection domain. Volumes are created logically from the storage pool. Each volumes is actually distributed across all SDSs and devices to a very small chunk, i.e. 256 MB of chunks for medium granularity storage pool and 4 kilobytes of chunks for fine granularity storage pool. Okay, so far we have tested the PowerFlex system using 80/20 read and write percentage and 4 kilobytes I/O size. To see the maximum of IOPS that the system can deliver, we can use different profile like 100% read and 4 kilobytes I/O size. We will also take a look at the latency of this operation when we stretched almost to the limit. Let's kill off the current benchmark process and start again using new benchmark profile. Let's use hero number 100 read 4 kilobytes I/O size. Okay, now the benchmark process is kicked off again. Let's see what happened in the dashboard. You could instantly see that the IOPS now jumps to 1.6 million IOPS with bandwidth around 6 gigabytes per second. Please note that this is pure random read operation. Take a look also at the latency. We still maintain under 0.5 millisecond even when the system reach almost maximum IOPS number. Let's take a look again at glance per PowerFlex component. Let's first off start with protection domain. As you can see, the IOPS, bandwidth and latency for this protection domain is the same as shown in the dashboard for PowerFlex system level since we only have one protection domain. Now, let's look again at glance on SDS level. You see again the same amount of IOPS and bandwidth are distributed evenly and there are no hotspots. Latency per SDS are very low, down to 0.2 milliseconds, which is extraordinary. Now let's take a look again at the devices level. Here you see all read operation are done evenly on all the devices or disks. Again, no hotspots. Alright, now that we have tested the highest IOPS that the system can reach, and now we would test the highest bandwidth that the system can sustain. We will use 100% write operation with IO size 32 kilobytes. We will also take a look at the latency of this operation when we stretched the system almost to the limit. Let's kill off the current benchmark process and start again using new benchmark profile. Let's use 100% random write and 32 kilobytes IO size. Okay, now the benchmark process is kicked off again. Let's see what happened in the dashboard. You could instantly see that the bandwidth jumps around 11 gigabytes per second. Please note that this is pure random write operation. Take a look also at the latency. The latency of write increased to about 2 milliseconds. This is quite normal for large write operation and still considered very fast for write. Now let's see again and verify that the distribution of those bandwidth are still even across protection domains, SDS, devices, and hosts. Let's take a look at protection domain first. You see from the protection domain level it is the same as the system level. The bandwidth is noticeably very high to 11 gigabytes per second and latency around 2 milliseconds. Now let's take a look again at the SDS level. Those write bandwidth are seen distributed evenly to all 6x SDSs, and the aggregate is the same as in the protection domain level or system level. Do note, since PowerFlex uses Ethernet network, to deliver this optimal bandwidth or throughput, we need to design the network properly. Typically, PowerFlex nodes are equipped with 4 ports of 25 GBE. Let's take a look again at the device level. You can see all those write bandwidth are evenly distributed to the devices and no hotspots. Alright, that's all about PowerFlex performance demo. To summarize, PowerFlex 1 is a really massively distributed and scale-out software-defined storage design for hyperscale data center, although you can start small as well. 2 is really high-performance storage system and can deliver million IOPS, hundreds of GB/s throughput in just small number of nodes or rack units. 3 is very flexible and open software-defined infrastructure which supports multiple hypervisors and bare metal operating systems. Thank you again for your attention. Stay tuned for more IT technology contents. Don't forget, please like, subscribe, and share.